Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at the continuation of the trigonometric derivatives of trigonometric inverse function. So this is example number 20. So please urge that if you have not watched the previous lessons, you can just check them up in our previous lesson, and at least you have an understanding of how to find the derivatives of the trigonometric inverse function. Now, most times to find the derivatives of the trigonometric inverse function is not really a problem, but to reduce its derivative to a simple form, like the simplest of all, in fact. Now, for instance, this problem has an answer of 1, positive 1. So it means that after we have found the derivative of this trig function, we must be able to bring in some trigonometric identities and simplify its derivatives. So just pay attention. We want to solve this problem, and you want to use the steps that we want to use to solve this problem on your own. So it's just the same. We only change the sound between them. So it's nothing big about it. Okay, so let's go. Now, we know that the derivative of tangent inverse of x is just equal to 1 all over 1 plus x squared times the derivative of x. Now, so to find the derivative of that function y prime, I'm just going to do it straightly. In some books, the authors allow this to be our u, that is, use the chain rule, substitute this expression with u, differentiate this with respect to x, and then also differentiate this y with respect to u, and then you can find your dy by dx. What I mean is that the author allowed this to be u, so he needs to find du by dx. So after this is being substituted with u, it means you have a function now in u. So that is dy by du. So if you multiply the two of them, you will have, because the du and the u can cancel, you will have dy by dx. So you can also use that method, or another way you can do it is to take this expression out first. That is the cos of x plus sine of x divided by cos of x minus sine of x. Take it out of the argument and simplify it. Either you can rationalize it and then bring in some trig identities to simplify it. But I'm going to do all of those ones later. So let's just go straight into it. So now I want to differentiate that function. So I have 1 divide 1 plus what? 1 plus, this is x. So the angle now, this entire thing is x. So it should give me cos of x plus sine of x divided by cos of x minus sine of x. So this whole thing is square times the derivative of this particular expression. So for this expression now we can use the chain rule. So remember the answer is positive 1. So we can use the chain rule. We hold the denominator, that is, we hold cos of x minus sine of x, and we differentiate the numerator. So the derivative of cos of x is just minus cos of x, sine of x, plus the derivative of sine of x now is just cos of x. And then after doing that, we'll move within the denominator. Remember, this is cos of x. So we hold the numerator now, cos of x plus sine of x, and differentiate the denominator. The derivative of cos is just minus sine of x, and the derivative of sine of x is just cos of x. All divided by the denominator all square. So it's cos of x minus sine of x all square. According to the quotient rule, because the quotient rule says uv minus VU, that is, you hold U and differentiate V, you get V prime. You hold V and differentiate U, you get U prime all over. Now the one that you are holding first is your U squared. So if you have like Y equals to V all over U, that's exactly it. So we hold the U and differentiate V, minus we hold the V and differentiate U. That's the quotient rule. That's exactly what we're doing. So the next thing we need to do is to simplify. That's all. Nothing else but just to simplify. So Y prime now becomes now 1 all over. So this expressed over 1. Now this denominator can have its own power. So this is 1 plus cos of x plus sine of x times cos of x plus sine of x. We're just doing it little by little so that you understand. And then this denominator, cos of x minus sine of x all square. Now, one of the reasons why I don't want to expand this one now is because I'm seeing the same cos of x minus sine of x all square. So this can actually cancel this. Now, this side now we have cos of x times sine of x is just minus sine of x cos of x. And then cos of x times cos of x is plus cos square x. Sine of x times sine of x is plus sine square x. And then sine of x times cos of x is just cos of x. Or I take the sine of x first. So it's sine of x cos of x. So this is just for this first term, right? So now we know between here, cos of x plus sine of x is just equals to 1. So we can reduce this. Then this and this are like terms. We can add them. So I'm just going to reduce them. So because there's no space, so if we add this and this, we're going to get minus 2 sine of x cos of x. And then this will just give us 1. So this whole thing will just give us 1. Okay, so now let's move to the next one. Cos of x times minus sine of x. So minus it and minus give us plus sine of x cos of x. Move to the next one. Cos of x times cos of x is cos square x. Negative and negative is positive. So it's positive cos square x. Sine of x times sine of x again is positive because of this negative. So this is sine square x. Sine of x times cos of x again is positive. So this is sine x cos of x. So we can cos of x, cos square x plus sine square x, we know from the Pythagorean identity, that is cos square x plus sine square x is equals to 1, like we did in the previous one. So this will just give us 1. And then we can add this term and this term together. So in the denominator, we have cos of x minus sine of x all square. So it's just very easy. There's nothing difficult about the problem. This problem is very, very easy. So now, y prime now equals, again, 1 divided by. So we're going to multiply this expression by this. So it's going to this will just give us cos of x minus sine of x all square plus. Now, so if we multiply these two, we're going to have cos square x plus, and then this gives us sine of x cos of x. So let's erase the problem. Remember, the answer is just 1. And then this time, this gives us sine of x cos of x. And then the last one is just sine square x. So again, cos square x plus sine square x is just equals to 1. And then we can add these two as well, right? Now this entire expression now is being divided by cos of x minus sine of x all squared. And also what is here? Remember we have now 2 sine of x cos of x. This plus this is just equals to the same thing, right? So this and this can cancel. So 1, 2, 3 can cancel because 1 plus 1 will give us 2 sine of x cos of x, and then minus 2 sine of x cos of x. Between here is also 1. Cos square x plus sine square x is 1. 1 plus this 1 is 2. So the entire numerator is just 2 divided by this denominator, which is cos square x, cos of x minus sine of x all square. So what do we observe is that this can cancel this expression. So we will now be left with the problem is very, very simple. So now left with y prime equals, and this is now 1 times 2 is just 2. So we can expand this one. That is cos of x times cos of x minus sine of x times cos of x minus sine of x. So we can just expand it. So cos of x times cos of x is cos square x. Cos of x times sine of x now is sine of x cos of x. And then sine of x times cos of x is sine of x cos of x. And sine of x times sine of x is plus sine square x. So again, the first term and this last term is equals to 1, because if we add the two of them, it's equals to 1. And then we can add these two expressions between. So similarly, this first term and this last term is equals to 1. So this gives us 1. And then between here, we can just add these two expressions. So it's now positive 2 sine of x cos of x. So let's erase this. So y prime now becomes 2 in the numerator. So again, we said this plus this is just 1. And then we add this 1 plus this 1 is 2. So it's minus 2, and then it's plus 2. So this one go out. So what is left here? 1 plus this, and this is 1. So it's 1. So let's just bring this over. So what do we have? We have 2 all over 2, which is just equals to 1. So you see, to find the derivative of a trig inverse function is not really difficult. What is challenging is to simplify your derivative into the simplest of all forms. So this is how we find the derivative of tangent inverse of cos of x. I think it was plus of x in the numerator, and in the denominator it was minus of x. So you can do the problem that we have down for you to try. You can do that problem, and see you in our next lesson. Thanks so much for watching. Thank you.